welcome guys to the lesson on stratified sampling. And hopefully a number of you have done the survey I asked you to do, and we'll collate all that data and we'll use that. But this is just to explain to you what is stratified sampling. Okay. Now, first of all, what is sampling? Well, sampling is where you select from a group, a population. That population could be, say, the people in your house could be the population, the people in the school could be the population, the people in the city could be the population. It is just what you define as the large group. And then from that, you take small groups, units. So it could be the people or the chickens or the letters in a story. So you take those out, and that's sampling by taking those out. And the key here is that each unit has an equal chance of being chosen. And that's really important if you're going to do sampling. And there are numbers of types of different sampling methods people use. And I'm going to just explain three very quickly here, and then focus on the stratified one. The first one is random sampling. You've probably seen this. This is essentially where anyone could be chosen, and it's done by names in a hat, random number generator. Allocate numbers to people, put it into your calculator, press certain buttons, and it'll say, like, choose number 12, choose number 15, choose number 18, sort of a random generator. So it's anyone has a chance of being chosen. Now, that's useful, and often that's what you do to begin with on any of the others, but there could be some problems with that. Systematic sampling is a very quick method. Okay, so maybe you'll choose every fifth name in your telephone directory. Not that we have telephone directories anymore, but say you have a class register in order, and you then choose every third person or every fourth person, and that's systematic. And working that out is relatively easy. But with systematic, you'd always start off choosing a first person randomly, so that would be your start point. So again, we're using random sampling. So we would just first of all choose one randomly, and then do every fifth, every fourth, whatever it is. Stratified sampling is what we're going to look at today, and that is really powerful when you've got a variety of groups and distinct groups, and you want to make sure that every group has a fair representation, because sometimes that doesn't happen. And so we're looking at stratified sampling today, and we're going to look at it by looking at an example of our farm. And on our farm we have a variety of animals. We have pygmy goats, runner ducks, alpines, and chickens. And what we want to do is we want to get a random selection from there. Say, for instance, we know that there's a tick infection in Bath and northeast Somerset, and we want to find out how many of our animals have ticks. And you could look at the entire population and get all of them. But think about this, if you took the whole population, say we wanted to explore the TV habits of everybody in Bath, you're talking thousands and thousands, and that's going to take a lot of time, and it's going to cost a lot of money. So yes, you could do it, and we do have census, and every 10 years we do a census. In 1066, I think there was a massive census done, and that's where you ask everyone in the population certain questions. And you could do that, but that's very expensive. So is there a less expensive way? Well, yes, sampling. But of course, because you're not taking everybody, sometimes you might not get all the data you want. Okay, but it'll be cheaper. So let's take this as an example. So I've got all my animals, but they're always random. They always go anywhere they like. So I'm going to try and organise them. Okay, so I'm going to ask my animals to get in order. Okay, so I'm doing that, and yep, there they go. They've got in order. I put them in little boxes. They can't run around. You'll notice this looks very much like a pictogram, a picture chart. And yes, it is. And with picture charts, pictograms, you've got to make sure that everything is always in line, and equal spacing. Sometimes you can have one alpine represents 4, and so you'd have a quarter if you wanted one alpine. So this is a nice example of that. What I'm missing here is a key. If I wanted to make this a pictogram, I'd have to have a key representing what does each box represent. But for what I'm doing here is I'm literally just trying to organise it, collate it, and then I can do some random sampling or stratified sampling. So if I did random sampling, and I just selected these ones, I maybe put all their names in a hat, because every animal's got a name, put their names in a hat, and I selected out, then these are the ones I could choose. Now, the thing is, there's a problem here. I wonder if you can spot what the problem is. You see, right at the beginning, we said that sampling has to be such that each has an equal chance of being selected. And if you can see, my little pygmy goats, none of them are representative in my sample. And I really want them to be representative. They're fun, they're enjoyable, they're cheeky, but really everyone needs to have a chance of being selected. And because only 4 of them, by random sample method, they haven't made the hit, or the list, I should say. So is there a different method? Is there a way we can ensure that everyone has an equal chance, but I have a fair proportion of each distinct groups? And yes, stratified sampling. So I've got them in their strata, their layers, and that's important. So you first of all put them into their layers, their strata, their stratum, and then I number them. So I've got 8 alpines, 12 runners, 16 chickens, and 4 pygmies. So let's say I want to explore 25% of my 40 animals. So I just want to take 25%, but I want to do it by stratified. So what I'm going to say is I want 25% of the total. So 25% of each pet. Okay, because all pets, aren't they? So I'm going to say my multiplier is 0.25. Remember, multiplier is 25% divided by 100, 0.25. So my multiplier is 0.25, times it by how many alpines I've got, and that means I need to select 2 of those alpines. I do the same with my runners, 0.25 times 12, so I get 3 runners. I get my 4 chickens, because there are more chickens than anyone else, so they will be more representative in there. And then I get my 1 pygmy to choose from. Now I've done the stratified. Now I want to select my 2 alpines, and in this you do different methods, and I've got 2 methods here. One is random, so with 2 of these it's random, and 2 of these it is stratified. Now, sorry, systematic. Now, it's a bit cheeky really, because the goats you can't see this either or not. The pygmies, there's just one selected. So I'll give you that one. That one's actually randomly selected. But of the other 3, 2 of them are systematic, and 1 of them is random. And I wonder if you can work out which is which. Okay, so clearly you can see here there's a window, an equal size window in these ones. So here I had 3 runners that selects from. So I did 12 divided by 3 is 4. So I wanted every fourth runner. And I randomly selected start point, that came to 2. So number 2, you're in there. And then every fourth, so it's 4 from there. So that's my 5th, okay? And then that's my 9th. And so I've got my 3 representative there. Here with my chicks, I have 16 chicks. I wanted 4 chickens. So 16 over 4 is 4. So I wanted every 4th chicken. I randomly set the starting point. My random starting point was the 3rd one. And then my systematic one, boom, 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 boom. Now, as I said, with systematic, getting them in some order is important. Okay? Alphabetical order, whatever, that would be important. Now, if they're all the same, like these runners, it doesn't really matter. But often if you're looking at names, etc., that is important. Otherwise, it's not really systematic. So that's how you do stratified sampling. But I've got one more thing to tell you. What happens if the numbers aren't so comfortable? So say I wanted just 20%. If I just wanted 20%, then if you notice here, yeah, I've got 8. I want 8. And that's a whole number, that's an integer. That's easy. But look what happens. If I do 20% of 8, I get 1.6 alpines. Now I can't choose 0.6 of an alpine. I just can't do that. That's just not right. So therefore, I'm going to round 1.6 up to 2 alpines. Whereas with the runners, I need 2.4. but that's I'm going to round, so it's round down to 2. So actually I'm only choosing 2 alpines and 2 runners. And you may think that's slightly unfair, but that's just the way things go. Because these aren't whole numbers, that is the fairest way we could possibly do this. I get my 3 chickens and I get my 1 pygmy. And then as you can see, I have 8 in total. Now, had I chosen, say, 15% or 10%, then I wouldn't have selected any pygmies. So you have to be very careful with how much percentage you choose in order for it to work as well. So that's stratified sampling. I hope that's helped, and we'll talk more later.